Okay, here we go, guys. I need you guys to be quiet, please, because I am recording this. All right, and you really need to pay attention. All right, so the first thing I'm going to show you guys is this is one entire problem, and this is a short one. Okay, this is one problem. Okay, so I want to show you kind of everything we're going to be doing. Okay, today, this box right here, we're just drawing the problem, what's given to us. Okay, drawing the givens here. Here, I'm going to work with the moments about my truss, which is the turning force. We're going to pick a pivot point, and we're going to talk about how with every force applied at the other joints, how that pivots, how that rotates. In this box here, we're going to sum up all the forces in the x direction and all the forces in the y direction. And that's where we're going to stop today. We're only going to get through these 3 steps. And then when I see you Friday, we're going to look at each individual joint and analyze each individual joint to come up with the forces in each member in our truss. Okay? The other thing we will also do today is down here in the lower right-hand corner is where your answer goes. This is our summary. We will start our summary. So when I go to grade these, this is the first box I look at, and it will tell me if you did the problem entirely correct. It'll show me all the reaction forces if you have those correct. It'll also show me if you understand in each member whether we're in tension or compression. That's what the T and the C means, as well as you can see the values, the force in each member. Okay, so we'll start to draw this today. All right. Okay. Now, I'm not showing you this let me say it this way. You all are very capable of doing all these problems. Okay. The math is super easy. You're all very capable. All right. The organization, okay, is probably something for some of you that you've never been held accountable for in any kind of quote unquote math problem. Okay. But see these grids? This is going to help you organize all your information. Okay. So it's almost foolproof to the point where you can't not be organized. Okay. All right. All right. So here's where we're going to start. All right. Let me zoom in here at the very top. So I write this at the very top, and I'm actually going to include one more thing. At the very top of every truss problem I do, all right, there's SOHCAHTOA. That's how I write it. Just to remind me when I get to the point where I have to use trig, the different ratios, okay? Because sometimes if I get going too fast, I might mess that up, and this is always a reminder to slow down. Here's the ratios. SOHCAHTOA, sine, cosine, tangent, okay? This over here, okay, because this is, for some reason for me, this is hard for me to remember, so I write this down. When we go through and we find, starting in step 3, okay, the forces in each member, it's either going to be a negative number or a positive number. And that negative and positive sign is going to tell you whether that member is under compression or tension. So this is to remind me that a negative number, a negative value means that member is under compression. And then these arrows, and I'll explain this when we get to this on Friday, these arrows show me in the summary which way I have to draw my arrows, okay? Because that is something you have to do correctly. And then this reminds me that if I get a positive number, that member is under tension. And again, those are how the arrows are going to point, okay? It seems opposite. That's why it's hard for me to remember, okay? But that's how we do it. The other thing I write, okay, and I forgot to this first hour, so, and I had to go back and talk through it. So we've talked about this before. A moment is a turning or a rotational force, and you have clockwise moments. Clockwise moments are negative, okay? Clockwise moments are negative. Counterclockwise moments are positive. And I write that up there to remind myself of that. Again, this kind of seems counterintuitive, but clockwise negative, counterclockwise is positive. Okay? All right. Any questions so far? All right. So let's get into number 1. Okay? So the first truss we're going to analyze today is this, and this is the one from the notes on Monday in the presentation. After we changed this to a roller support. So now it's statically determinate. We can solve it, okay? And so what we do with any truss problem is we will be given a truss, and then in step 0, okay, which this is step 0, all right? So you want to write in step 0, we redraw the truss just like you see here, okay? So I want you right now in step 0, you're going to redraw this truss, label the joints, okay? Label the sizes of the members that are given to you. Also label the angles that are given to you. And then any applied force. Here there's an applied force at joint D going down. You'll also notice I have included the reaction forces. You have to also include those, okay? So take a second and draw this. Now here's what these mean, right? I have a pin support. I have a pin support, so I have 2 reaction forces. This means the reaction force at joint A in the Y direction. You need to label it the exact same way. Here I have the reaction force at joint A in the X direction. And they're up and to the right because in this step, I assume those forces are going in a positive direction. So anything in the Y direction, up is positive. Anything horizontal or in the X direction, going to the right is positive, okay? Over here at C, I have a roller support, so I only have 1 reaction force. And remember, for the roller support, that one force is perpendicular to the point of contact. So the point of contact, okay, is right here. Like this is the surface, all right? This is the surface, so this is always perpendicular to that, okay? Jackson, question?
What's that little thing in the corner by C?
Right here,
Yeah.
theta to represent. I don't, now this isn't initially given to you, but what happened is I went through and did this whole problem, and I had to come back and figure out this angle, okay? So eventually you're going to need that there. Just theta, Greek letter theta. All right, so take a minute here and get this drawn. Now here in this step, you could use pen. I would suggest not from here on out because guess what? You're going to mess up and you're going to make mistakes starting with the next step. So pencil's probably your best bet. Okay, the other thing you'll find as you go through this, labels are super important because you're going to get so much information that writing clearly and being able to pick something out of this quickly is going to be really important. Okay, so make sure you can read your labels and things are labeled appropriately. Make sure all your units, you use units every time you write a number, okay? You'll notice here, there's not a single number written that's just a number. It's 500 pounds, 7 feet, 53 degrees, okay? So make sure when we move forward, right, wherever units are necessary, there, which is most of the time, right, you always have units. All right, any questions on step 0 here? Okay, so we're going to move to the box to the right, and the box to the right is going to be called step 1. Okay, you can start to see it right here, step 1. All right, so in step 1, we are going to be working with the moment or the turning force. And we're going to pick a pivot point on our truss, and again, talk about how it would pivot with applied forces around that pivot point, all right? Now, the sum of the moments equals 0, okay? Because we are assuming our truss is in static equilibrium. It's not moving, all right? So the sum of the moments equals 0. Here, reminding us that the moment is equal to the force times the perpendicular distance to the pivot point. Okay? The force times the perpendicular distance to the pivot point. And that little perpendicular thing's important. Okay? All right, so this is how we start. All right, step number one, okay, and we have our information up here. How we start is we write the sum of the moments, that's sigma m, Greek letter sigma, sum of the moments, is equal to, all right, and moments are going to be applied at all of the different joints. So however many joints in your truss you have is how many of these next variables you're going to include, all right? So I have moment around subscript A, M sub A, that's the moment around joint A, plus the moment around joint B, plus the moment around joint C, plus the moment around joint D, okay? Because I have, those are the labels of the 4 different joints in this particular truss. Now, don't be a robot when you get to your homework and write this equation, okay? This equation depends on how many joints you have in that truss for that problem. So if I only have 3 joints, guess what? That's not going to be there. If I only have 2, I don't know how you make a truss. There's 2, but there you have that there. If there's 5, you can have plus the moment sub E or whatever they're labeled. They could be labeled with other things, okay? Everybody understand that? Okay. All right. So we have to pick a pivot point. So what do I mean by that? Okay, so when we look at our truss, how we pick a pivot point, okay, or in other words, where we are going to theoretically, the point we're going to spin this around, is we pick the point with the most unknown forces being applied to it, okay? So let me tell you this. At joint B, there's no forces there. There's nothing. So there's no unknowns, okay? At joint C, I have one unknown. I have a reaction force CY. At joint D, I have 500 pounds pulling down. I don't have any unknowns there. So at B and D, there's no unknowns. At C, there's 1. At joint A, I have 2 unknowns, RAX and RAY. So the pivot point, all right, is the joint with the most unknowns. So what am I going to pick here? A. Okay, I'm going to pick joint A. All right. So over here in step 1, what I'm going to do is I'm going to circle what I pick as my pivot point, okay, so that I don't forget. And then I am going to cross it out and put a 0 there because the moment at the pivot point is 0. Anybody know why? Why is the moment there 0? Whatever pivot point you pick.
Is it not rotating at all? It's just going to stay in the same spot.
Well, it's not going to rotate, right, but check out this equation. The moment is the force times the distance to the pivot point. If we're at the pivot point, what's the distance to the pivot point? 0, okay? So 0 times, doesn't matter if you have 1,000,000 pounds applied there. 0 times 1,000,000 would be 0, okay? Does that make sense? All right. Okay, so now we're back here. All right, so what I'm going to do next, all right, is now I'm going to break this down each moment into force times distance, okay? All right, and I'm going to replace sigma m with 0, right? Because we said the sum of the moments is 0, all right, equals the force at B plus the distance from B to the pivot, times, sorry, force times distance, force times, plus the force at C times the distance from C to the pivot, plus the force at D times the distance from D to the pivot. Okay. Any questions on that? Okay, so now let's go back and look at our truss. And let's see if we can make anything else here go to 0. Okay, so we're going to start with B. Is there any force applied at B? No. Okay, there's no force applied at B. So if the force at B is 0, 0 times the distance is, whatever it is 0. So I have another one that goes to 0. Okay? That's often, people forget about that. But if there's a joint where there's no force applied, it's going to go to 0 just like the pivot. Okay? All right. So now let's look. I'm going to start to rewrite this. Okay? And so I'm going to be just be dealing here with C and D. So let's look at C, okay? So at joint C, okay, all right, I have this force here, RCY, and I do have a perpendicular distance, okay? All right, the distance is easy. It's 10, right? 3 plus 7 to get from C to A. Now, the force is unknown, okay? So it's going to be, I'm going to say it this way, some version of RCY times 10. Now, here's where we have to think about, would this spin us clockwise or counterclockwise, okay? So if my pivot's right here, this is my pivot point, and I push up, and theoretically this truss rotates, which way is it rotating with this push up? Counterclockwise, okay? And again, here's a little demonstration, okay? If my pivot point's here and I push up here, counterclockwise, right? You guys were correct. So counterclockwise, is that positive or negative? Positive, okay? So when I come over here, the force at C is positive RCY. I know we don't know it yet, okay? But here, even though we don't know it, if that would have spinned us clockwise, I would have to write negative CY, okay? Times, what did we say, 10 feet? 10 feet, okay? Now we have to do the same thing for joint D, okay? So I'm looking at D, all right? What's the distance? 3 feet, okay? This time, here's my pivot, and that force is down, so it's pulling me this way. Which way am I spinning? Clockwise. Clockwise is what? Negative, okay? So this would be minus 500 pounds. Oops. Minus 500 pounds times that 3 feet. Okay. Now, here's one thing. Do not assume just because it's pointing down that it's negative. For the moment, for step one, okay? For step one, we have to go through and talk through how it would spin, okay? Because, like, if my pivot was at C and that 500 pulled us this way, now which way am I spinning? Counterclockwise, so it would be a positive, okay? So this box right here, you have to go through and figure out which way you're spinning. Okay, the direction that it's drawn initially doesn't matter here. Okay, all right, in terms of the sign you use, it's all about which way it spins. Okay, now I've got one equation, one unknown. Can I solve for RCY? Absolutely. Okay, all right, so I'll go through and I'm going to solve for RCY, simple algebra. I think this is really a kind of a 3-step, right? So first thing I do, negative 500 times 3 is negative 1,500. Foot-pounds. Yeah, just foot-pounds. We're going to add 1,500 to each side. Okay, notice I'm including the units the whole time. And then finally, I'm going to divide by 10. Okay, so 150 pounds equals the reaction at joint C in the Y direction. And I'm going to box that in because that's going to be something I'm going to include on my summary. Okay, now what does it mean that it's positive? Well, that means that here, okay, and remember in step 0, we always draw up and to the right, those reaction forces. The positive sign means that, yeah, we were right, it goes up, okay? If this would have been negative 150, then that would tell us when we go to the summary, we're going to draw RCY pointing down, okay? All right, so any questions there on step number 1? Okay, so now we're going to move here to step 2. Okay, so in step 2, what we're going to do here is we are going to add up or sum all the forces in the x direction. And I'll explain to you what those are in a second. And we are going to assume that those equal 0 because, again, we're in static equilibrium. Our truss is not moving through our house, hopefully. Okay? And then we are going to do the same for all the forces in the y direction. And so typically what I do here is I kind of split this right down the middle. But again, usually you're going to have more work for one or the other, okay, depending on how many of each type of force you have, okay? Now, here's what I mean by the forces in the X and the Y direction. We go back to that step 0, all right? And I only take into account the forces I've drawn, okay? So anything that's applied, so we use any applied force. In this case, we just have one applied force, this 500. And then we take into account all our reaction forces. So if I start with the sum of the forces in the X direction or all the horizontal forces, how many horizontal forces do I have here? I just have one, okay, RAX, which makes this pretty simple, all right? So if I say the sum of the forces in the X direction equals 0, all right, and if I add up all the forces in the X direction, the only one is it's RAX, but there's nothing to add to it because it's the only one, equals 0. Okay. All right, so that's that value. 0 pounds, really. I mean, you don't have to include the pounds here. If it's 0, don't worry about units. Okay, not going to be that picky on it. We got enough going on. Okay, so sometimes your reaction forces will go to 0. Okay, they will. All right, so don't think you've done something wrong if a force goes to 0. All right, so any questions there on that one? All right, so let's add up the forces now in the Y direction. So if I look at step 0 again, how many vertical forces do I have here?
3.
I have 3. I have my 2 reaction forces and the 500 applied force, 500-pound applied force. Now, 500, obviously I know, it's 500. RCY, we solved for in step 1. So now I know 2 of the 3, I can now figure out this one, okay? All right, so here's how we write this out. Add up all the forces in the Y direction. I have the reaction at joint A in the Y direction. I still don't know that one. Now, be careful here. Now direction is important. That 500 pounds is pointing down. So this is going to be minus 500 pounds. Okay. And then, okay, you always need to start it like you see here. Okay. I know we already know what RCY is, but I want you to write it first with the variable, because if you don't, you're bound to mess up the signs somehow. Okay. So it's plus RCY equals 0. Then plug in what you know. I know we all like to skip to plugging things in right away because we can get to figuring things out right away, but here you have to take things step by step, okay? So RAY, I don't know, minus 500 pounds. Okay, RCY is 150, okay? So plus 150 pounds equals 0. And now I have one unknown in my equation. I can solve this for RAY, okay? Negative 500 plus 150 is negative 350 pounds. And then I add 350 to both sides. So the reaction at joint A in the Y direction equals 350 pounds. And again, I'm going to box that in because I have to include that in my summary, my answer. All right. Okay. Step 0, we drew it, okay, and put the forces there. Step 1, we work through the moments. We pick a pivot point, we work through the moments. Step 2, we sum up the forces in the X and the Y direction. These 3 steps will be the same every time, okay? What starts to change is when we get to step 3, which we're going to do Friday. That's going to be different for every truss, okay? Because then we get into the joint analysis, okay? But the last thing we're going to do today is we are going to start the summary, all right? So you're going to move to the square in the bottom right-hand corner. And this is always going to be your summary, no matter or not if we use all these boxes. This is always your summary. If we get to here and we have to do more analysis on the joints, we're just going to flip it over and start to work on the back, okay? But the bottom right-hand corner is always our summary. So S-U-M-M-A-R-Y. All right, so how you start to draw this, all you draw are the joints, and you draw them relatively speaking to how they are on the truss. Okay, so this would be joint A would be over here, joint B, joint C or D is right underneath, and joint C is kind of stretched out over here. All right, now understand Friday, eventually we will draw all these lines between the joints. So anything that we did today in terms of applied force or reaction forces, we want to keep out of there, okay? So the first force we figured out was the reaction at joint C in the Y direction, and it's positive 150. So down here, okay, I'm going to draw it like this because it's out of the way, 150 pounds. It points up, okay? It points up to tell me that it's a positive force, okay? Now, this force right here, the one that's 0, we don't have to include because it's 0, okay? It's just a waste of time. Don't include it. Our AY is 350 pounds. It's positive. So again, we draw that up. And then we want to include any given forces, which we had this 500 down right here. Units must be included. Okay. Now, one thing you didn't see in this example is if we have a negative force, how do we draw it in the summary? So, okay, hypothetically, let's say this was negative 350. Okay. We would come down here and we would draw it. The arrow would go down, okay, to say that it's negative. So we would write still positive 350, but we understand since this arrow's down, if we have to do anything mathematically with it, it would be a negative force. Does that make sense? Okay. All right. Okay. And obviously, as we work through some examples, that'll become easier and easier for us. Okay. So any questions, whether it's online or here in the classroom, anything with those 0, 1, 2 steps and the summary? All right, so grab another piece of gridded paper, okay, because we only do one truss on each sheet, so grab another. Let me know if you need extra. Need a couple more? Okay. Okay, you guys at home, start a new sheet. You got, you're going to need 2 total. I'll bring you more, okay? All right, so we have 2 homework problems, okay? We have 2 homework problems, of which we need to get steps 0, 1, 2, and start the summary done before we get here on Friday. Okay? All right? And for you guys at home, on the slide, they're right here, truss homework problems 1 and 2. For you guys here, I'll bring them up in front of you here. Now, what I do for the first few trusses is I include the answers. All right? For you guys at home, so you know, okay, if you're doing things right. Here in class, we're going to work through it together, okay? But what we need to do first, okay, is this is homework problem number 1. All right, we need to draw step 0, okay? Now, hint, hint, I have done it on the board for you, okay, so that you, as you go, all right, you know what you did right. So here's number 1, okay? So step 0 for homework problem number 1, and then I'll bring some more sheets around. This is step 0 for homework problem number 2, okay? I've also started step 1 for you and circled the pivot point, which that should be pretty obvious. We all kind of understand where the most unknowns are, all right? And then you guys are going to work through, like I said, step 1, step 2, and start your summary. And you need to check them today to see if you're doing things right, so that Friday we can start right away with step 3, which is where we start to use trig. All right, and where things start to get a little bit more complicated. Okay, all right. So go ahead and start your steps. Truss 1. All right, work yourself through that, and then get to truss 2. You guys at home do the same thing. I'm going to keep the my mic on. All right, I'll keep the volume up. So if you guys have questions, all right, please ask. Don't hesitate. Okay.